Hi, this is Mr. Lyons. In this video we're going to discuss the dot product of two vectors. We're going to also look at the properties of dot products, and we're going to use dot products to find the angle between two vectors. So let's get started. First of all, what is the dot product of two vectors? Let's define it. So if you have two vectors v and w written in algebraic form here in their I and j components, we find the dot product by multiplying their I components or horizontal components. Let's see if we can circle that. And we multiply the vertical components or the j components. And then we just add those two products together. That's the dot product, it's called, of two vectors v and w. So let's look at some examples of finding dot products. So we have these two vectors v and w. Let's take a look at example A here. What is the dot product of v and w? Oops. Put it in draw mode. Okay, so we have v dot w. And we're going to multiply the horizontal components of the two. So we have 2 times -3 is the horizontal component of w. We've got the vertical components that we're going to add the product of here. So we have 5 times 8. And so that's going to be equal to a -6 plus 40. So our dot product of those two is 34. Okay. What do you think is going to happen when you do w dot v? Well, let's do it real quick. Okay, so we've got -3 for the w horizontal component, and the horizontal component of v is 2, and 8 is 5. So I'm getting ahead of on the properties here, but it looks like the dot product is commutative. Okay, so let's move on and look at v dot v. I'm going to erase these. Okay, so v dot v. It's just going to be the horizontal component of v times the horizontal component of v. And we're going to add the product of the vertical components of v, which is 5 and 5. And so the dot product of a vector in itself is just the square of the horizontal component plus the square of the vertical component, isn't it? Which we've been using a lot to find magnitudes by doing that sum of the squares and taking the square root. So let's solve this over here. So this is going to be 4 plus 25, which is 29. So let's look at E, the magnitude of V. The magnitude of V, and we all know we've done this quite a few times now, is we're just going to square the horizontal component of V and square the vertical component of V, add those together and take the square root. So we can conclude then that v dot v is going to be the square of the magnitude of v, isn't it? Alright, let's move on. So here's some properties of dot products. We just discussed the commutative property. The distributive property also works with dot products. So if I have two vectors v and w, for example, that are added together, I want to take that resultant vector and dot it with u, if you will, or take the dot product of it with u, then we could actually also do that by taking the dot product of u and v and the dot product of u and w and adding those two dot products. We already talked about the magnitude of v squared is equal to v dot v. And then we've also talked about the zero vector, which really is just a vector of zero length, or is a point, be the initial point. And so that would be at the origin. And then if I take that zero vector and dot it with another vector, then the result is always going to be 0. So how do we use a dot product to find the angle between two vectors? Let's look at an example here. Oh, wait a minute. Let's define it first. Okay, so how about the law of cosines? You guys remember the law of cosines, right? But now we've actually made our triangle with vectors. So let's take a quick look at this thing here. So it says here down at the bottom that the magnitude of u minus v squared. Okay, so they're squaring the length of u minus v over here. Let's get back there. Okay. So that's the length of this vector squared is equal to the length of the u vector squared plus the length of the v vector squared minus 2 times the length of u and length of v times the cosine of the angle in between them. So yeah, that is the law of cosines using vectors. So we could rearrange this so that we have the cosine of theta is equal to u dot v divided by the magnitude of u and the magnitude of v, the product of those two, I should say. Obviously, there's a little bit of simplification that goes on there. If you'd like to see more detail, you can take a look at that in the book. We're going to use this derivation, though, to find the angle between two vectors, so let's try it out. So what if we have these two vectors? I want to find the angle theta between the two vectors. Why don't we go ahead and graph these roughly over here just to make sure that we know what we're looking at. So I'm going to just make a small graph over here. Take a look at these two. Some y-axes. Okay, and I'm just going to roughly plot these two algebraic vectors. So we have horizontal 2 and a vertical 3. So here is the terminal point of u. Draw in vector u. And we have a vector v of 4, negative 8. Leave myself enough space, hopefully. 2, 3, 4, 5, 6, 7, 8. Okay. And so horizontal vector or component of positive 4 and negative 8 for the vertical component. So our point down here, I'm going to make it a little bit larger. There we go. Okay, so that's our terminal point. Back to the here, and let's change the color so we have a different color for this one. Try purple out here. So here's our vector v. And so we're looking for the angle in between these two. And that angle we're going to call theta. Okay, so using the dot product over the magnitudes of the two vectors multiplied together, let's calculate the dot product up here first. So u dot v is going to be the horizontal components multiplied together, 2 times 4, and we're going to add to that the vertical components multiplied together, which is 3, negative 8, Okay, and so our dot product is going to be 8 minus 24, which is a negative 16. And so let's take a look at what the magnitude of u is. Let's move that over here. So the magnitude of u is going to be the horizontal and vertical components squared and added together. So we have our 2 squared plus our 3 squared. And then we're going to take the square root of that. Okay, so that's 4 plus 9 or 13. So this is the square root of 13. And then the magnitude of v, let's do that down here. The magnitude of v, like this guy, is going to be the square root of our 4 squared horizontal component, and our vertical component is negative 8. Negative 8 squared. Add those together, take the square root of the result. And so what do we end up with here? So we have 16 plus 64, which is the square root of 80, which is going to be 4 root 5. Okay, so now we can find out what the cosine of theta is equal to here by plugging in the numerator and denominator stuff here. So let's put in our dot product of negative 16. And we have a magnitude of u, which is the square root of 13. And we're going to multiply that times the magnitude of v, which is 4 root 5. Okay, so we have negative 16 over 4 root 65. And, we could simplify this by rationalizing the denominator and all that good stuff, but do we really need to? We have our handy-dandy calculator, so we can just plug that in to our calculator to find what theta is. And so you guys do that while I'm doing it here and see if we get the same answer. And let's make sure that we're set in degrees. We are, okay. And so I'm going to have negative 16 inverse cosine negative 16 divided by 4 root 65 and I have approximately theta is equal to, I should say, 119.7. Okay, that's all for this video. See you next time.